kind of the conceptual aspect of the solar electricity that we play with here. Now wind, our power module, power organizing module, will take input from wind, just like it takes input from the sun, just like it takes input from a generator. So wind becomes a part of it, and this is the history there and here. You know, the one that we did first, that one spun for 20 some odd years with no maintenance. Then this one almost took off and left the ground, but showed us that if you get this lever arm, see this is a cylinder. You make it into a sphere with a longer lever arm, and the thing starts in lower winds. And this thing thundered out the power. We hooked 2 generators up to it. So we made kind of a combination between the two, and this thing is silent, and it's a piece of art, and they're making a special generator adaptation for us now from some generator company, and then this thing goes on the market. Still, we don't want to build them and ship them. We're putting out really, really detailed drawings as to how to build it. We'd rather do that. But it comes from playing with vertical axis windmills and propeller type windmills, both. And the propeller types, just every single one I've had breaks. Now, you'll get Popular Science or whatever, Outback or whatever magazines. I've seen analysis of vertical axis versus propeller type windmills. In every one, they say vertical axis windmills are not worth playing with, because they took a certain wind, and for an hour they tracked the power on a propeller type and tracked the power on the best vertical axis they could find, and the propeller type makes a little more power. And I don't argue that. That's the truth. But I argue with their test. Their test is for an hour. What about testing for 5 years? Test for 5 years, it's the hare and the tortoise. Test for 5 years, this thing spins faster, makes more power. But it goes down. It breaks. Now when it's broken, you have to pay to take it down, ship it off, wait for a month or so to get it fixed, bring it back, pay to get it put back up. You're down for 2 months. While this thing is just spinning away, quietly spinning away, not costing any money or time. So if you factor downtime and expense into the whole equation of the analysis, comparison between a propeller type and a good vertical axis after 5 years, less expensive and probably more power, because it's never down. It's always there spinning. And it is true, that thing that one was a lot more shoddily built than that one. And it spun for 22 years with no maintenance. It's got these pillow block bearings, and the only thing that finally did break on it was the blades started coming apart, and these are so much more reinforced than even those. And now the building is coming apart, so we got to do something about that. Well, this thing, that's steel. That thing is going to be there forever, and quietly cranking away power. Less than the propeller types, but more reliable. So I'm down on propeller types, and I think there's a lot of things that are that way. You analyze something for an hour, then it performs better. You analyze it for 5 years, it's radically better the other way. So it's looking at things, adding time to the equation of our analysis and opinions of where to go from here. Yeah.
You have your vertical axis wind turbines look like they're scooping the air, they're drag based, as opposed to like airfoil based one using lift.
Yeah.
Have you experimented with the other kind at all?
They had some over here at before the hive became our property, just the blade kinds, and I think they're probably very similar. I haven't got that much experience with the foil kind. I don't have anything against them. I think again they fall into the same thing of being compared to a propeller type and not producing as much power. They're lighter. I forget whether, I think they made some noise. I don't think they're quiet. There is a swoosh, swoosh, swoosh with them. And the part of the reason I've stayed with these is because they're just quiet. I don't know why they're quiet, actually. And we've gone to the sphere versus the cylinder over the leverage issue. So I have, to answer your question, I don't know enough about them and don't have experience with them enough to say, is there an advantage over this?
Well, these ones are probably quiet because they're moving at the speed of wind, whereas an airfoil is going to move 2 to 3 times the speed of wind.
Yeah. So that might be why it has noise. These are aimed at people in a small town like Taos being able to make them. And we experimented with that. We sent our drawings to Prague because we had a show there, and they made one. By the time we got there, there was a windmill spinning. So it came from this, where we started, and like I say, this was really, really funky, to tell you the truth, and then went to that, and that thing took off and blew all over the mesa, and we had to reinforce it, and then it still it needed to be rebuilt. It was just too much power. I mean, I watched 2 generators peg 2 meters, and it was that thing was fantastic. This one we scaled down the diameter a little bit to get it to stand like this. So see, that one's got a cage all around it, and this one doesn't need the cage. Well, it's got a cage, but it's kind of built into the stand. So it's an evolution, and we think a good evolution. But we have a lot of experience with vertical axis windmills, which led us to that one. We got grants to then try and build them into houses, and you know, this thing is dangerous. I mean, you get a kid up there, it'll take his head off. So, I mean, same story with this one, but they got to be high enough that you can't just walk up the roof and get your head caught in it. So that led us to this, and this. Here is evidence that it is quiet. That's the way it works in politics. It's a quiet windmill. And so we're building these into every project we can. There it is under construction. There it is being tested. There it is spinning. That's the wind in my camera. It's making that noise. There it is in New York City. Not there yet, but we've designed a building that is going to have 2 up on the very top of it. I believe I showed you this building. It's where we're taking the sun and bending it on an 80-foot mirror down into a global model airship. And that's what it'll be like in the building in New York City. The sun's coming in from above into that greenhouse. And that's the thing being transported. I mean, freight on these things would be, I mean, they ship bigger stuff. I mean, we could build them. We could make a factory here. Who knows? By 2 academies from now, we might turn people loose in the windmill factory. You never know. But it is, this was where the major reinforcing had to take place, this whole connection. These are, of course, washing machine and refrigerator panels to have some aspect of our real presence in there. There it is with the crane being lifted up. It all fit together perfect. Works good. We are now tearing out the tire. That was a good sort of quirky thing because we use tires to build with. But we've got a generator that's it's the magnetic disc kind where you just are dealing with a force field. There's no friction, and it's just a higher tech thing. So we've got it set up where we can unbolt the tire and slide this one in, and it's on its way actually. So then, because you see this thing, it takes a stiff wind to spin this thing. Now it is the way it is, and the smallest little wind will spin the new one with the magnetic generator. But it's a cool thing, and it makes power, and it makes power if wherever we have them, they'll just be there making power for the next 20 years. So rather than us making it and shipping it, we are putting out a very thorough set of drawings on how to build it. And like I said, now we'll have to change these drawings because we're unbolting bolts, taking this stand off, dropping the tire out of there and putting in a whole new axle with disc magnetic generator that is way better than this situation. But it was cute, you know, to have the tire turning the axle and turning the generator. We jumped on it when we first thought of it, but it's not as good, yeah.
Are they going to be specific size, like you can't adjust the size? Or is
Well, we'll probably have a small, medium, and large or something like that. Like I'd like to, yeah, now that this one is working as well as it is, I'd like to have a 10-foot diameter one as opposed to a 5-foot. I believe that's 7 foot or something like that. You know, having a bigger one, built the same way, just thundering out more power. And the drawings will probably be set for that. Right now these are set for that size. But it's got the yellow there is the shaft, the frame, and the stand that just mounts on a 6-inch well casing. All the parts and pieces are there. Can be made in a machine shop of a small town. That's the idea. Every piece, blades, it's not that complicated. They were able to follow it in a different language in Czech Republic.
Cost of manufacture?
Well, we got a lot of R&D into ours, so we have 10 grand in ours. I would say if we started replicating, we could get it down to around 4. Blades, power takeoff, which we're changing, power takeoff shaft. So we will have evolved this set of drawings now in a matter of weeks to be.
It's a vertical axis.
Yeah. To be a product of what the drawings is the idea that it's not rocket science there. It's pretty simple as long as dimensions are worked out and connections are worked out. It's a bunch of welding and parts and pieces that you fit together, you know, on the order of Legos or something, and you build your own power module that'll make power for 20 years. Yeah.
What's the cost of that new generator that you're putting on it?
It's going to cost $1,500 for the first one itself. And so we're still, you know, this thing is too expensive. But then once we start mass producing the whole thing, we're looking at a target thing of $4 grand for the product as you see it there with the new generator.
How much is the drawing?
The drawings are probably going to be $500 or so. And they're still going to be evolved. They'll eventually go down themselves. Right now we got thousands in the whole process, and once we get the drawings finalized and another unit or two finalized, everything, just like everything else, will go down, down, down.
And the maximum is 600 watts or something?
Well, with our new generator, we don't know what the maximum is yet, but and we'll have to put out that information too. And we are doing a little, when we get our new generator on this one, we have another one over here at the architect's building, and we're going to have amp meters on both of them and read them both out in the same winds, compare them, and be willing to say that even that little one may produce a little more power. I'm not sure with this size of this, but that little one has been down, I don't know, 3 times already. So that's the solar wind. When did we start? About 10:30 or something like that? So you're probably lunchtime, lunchbox material. Any other questions? We're going to do, then the other 3 things I have are, one is the disaster relief, which is pretty interesting application of all of this in different situations, and retrofit, which is a definitely open-ended dilemma conversation, and custom. So those 3 things will probably kind of cram into 1 or 2 sessions again before I go to California, Sweden, and Montana. Yeah.
May I ask a question which is not related to this session? I built an outlaw septic tank, but I didn't isolate it with the plastic sheet. So what are my options then? Can I leave it just there?
Yeah, it's just going to pollute the ground. But that's what septic systems do, conventional septic systems do. I've got one like that. I've got a hole with a stack of tires and the toilet flushes into it. It just pollutes the ground around it with the effluent, but that's what they do anyway. That's, you know, a normal septic system. a normal septic system has a tank that takes the solids and they go to a drain field in the ground, and everything leaches into the ground. That's the way the Environment Department says it's supposed to be done. So if you have an outlaw septic tank with a stack of tires in it, that the solids stay in the tires, so the anaerobic process still takes place. It just goes into the ground like a conventional one. So it's not a crisis. If you had 50 of them in a 1 acre area or something like that, it'd be kind of squishy on the ground. But it's not a problem. If you want to contain that water and get some use out of it, then it's better to line it. And we line them with rubber here, but in third world countries, we line them with 4 layers of regular plastic, just so we can contain. And so there's maybe a minor leak or something. So we're containing sewage is our biggest effort. Yeah.
Have you tried to make gas with wood, like there used to be in the past, well, before natural gas was installed? Because I've seen a lot of videos from here, States, that they are making gas and even move vehicles with that.
Oh yeah, you can. Gas from these outlaw septics would be. See, they're so cheap to build. You could build 2 of them, and have one being used while the other one's making gas. And we'll be playing with that in the coming months, years. We just have reduced the amount of need for gas in these buildings to the point of it's not high on the list. And of course, for automobiles, if you change an automobile around to run off of gas, methane, then you got a reason to start producing it there. For sure.
Yeah, but I meant not the gas from the septic. I mean, making gas with wood. Burn the wood.
We haven't done that.
Because that is really cheap. You have like two small containers and you burn the gas, but you use you half burn it, and you take the gas, which has a little bit of hydrogen, a little bit CO1, and that runs a motor, and it's quite simple. And you can burn plastic, you can burn whatever you have there.
I've seen a couple of devices like that. We haven't gotten it into our realm of very simple things to put out there yet. Same thing with hydrogen. It's just not simple and economical enough for us to play with yet. We have no problem with integrating anything like that comes along that is developed enough for us to just start using. If we're going to have to develop it, we're developing a lot of things right now, so it'll have to find its place on our list. Yeah.
Going back to the electronics, I'm thinking if we're going to build in Sweden and have a power module that is going to be suitable for the regulations and laws and the environment, I'm just having ideas that you could, like there are systems now where you can sell what you produce to the grid, so you can be connected and you can sell to the grid. And like in Sweden we have so much sun in the summer, we have like 16 hours a day. So you probably like charge your batteries, during the 4 first hours, and then you can sell the rest and make a bunch of money out of it. So I'm thinking, like my kind of question is, have you ever thought about designing an on-off-grid system that kind of takes advantage of all the laws and regulations and what you can do, but at the same time you make sure that you're producing your own energy that you use? So you're independent, but at the same time you're making money out of the grid.
It's called a grid tie system, and they do a lot of them over here. And we don't do them for a few reasons. One is the grid tie systems are designed for an existing house. You spend $80,000 for a power system, and that's what it takes to run a conventional home. An Earthship type home uses way, way less power. So the power that it would take to run your facility, or that one next door, or any home, is so small, it's just not worth selling to the grid to buy the $3,000 piece of equipment that you need to tie to the grid. What we suggest doing in that situation is that if the grid's there, hook up to the grid. And then have, here's your battery box and your batteries, and you have the grid come into your house to a small panel, and you just you buy the grid to charge your batteries during cloudy times. As far as you having enough power to sell to the grid to make it worth your while to sell it to them, you're probably not going to have enough. These buildings, the power systems, even to get them down to $25,000 is still a small amount of power that's just, it's peanuts to the grid. You're going to make, 47 cents a month off of it or something. It's just,
I mean, we have a lot of sun during the summer.
but I mean, you could beef up your system so that it would be worth selling to the grid, but then you spent more money there. So my angle there would be, one, get wind. I don't know if you have much wind where you're going to build. If you don't, then it's not worth spending $4,000 for wind. Then have the grid come. I used to say don't hook up to the grid, but I don't say that anymore. I think hooking up to the grid is a good thing because it's there to back you up. Use grid as a backup. If the grid completely goes away, then, which it could, then you've got your own system. So using the grid as a backup is fine because it's there. But the point being, your system that would run your entire visitor center is not going to produce a significant enough amount of power to send back to the grid. Now here's another thing with with the grid tie systems. They don't have battery. Most of the ones here, they don't have batteries. See, they just use the grid as their battery. They give power to the grid gives them power back. And everybody thinks that's a great thing. Well, when the grid goes down, you got nothing. You know what I mean? You got nothing. And the grid does go down. So, for all of those reasons, I'm just saying, okay, if the grid's there, get the grid brought to your building, hook it up to a 100-amp panel, and charge your batteries with it if and when you need it. Yeah.
Have you ever used hydro for power?
Hydro what?
Like,
Oh, hydropower.
yeah.
Yeah, we have actually in a few instances. It's just like the wind. It's a propeller turning that turns a generator and it goes right into our power module. Our power organizing module will take it from wind, hydro, sun, generator, or line grid. Yeah.
What's your take on earth bag construction? Just any experience?
Earth bag. Is somebody doing earth bag around here? It's very much like tire construction, more limiting in that you have to have the bags. You have to buy the bags and get them to wherever you're going. There's not as much of a coefficient of friction as with tires. You're a little bit more limited in your shapes, how you attach wood and things to them. In other words, I think it's great. I think it's better than frame. I think it's better than straw bale. I don't think it's as good as tires. So I don't use it not to badmouth it. It's just tires are better. Tires are better for me because I can go anywhere in the world and they're indigenous there. I can gather them. I've got details all worked out. I got a variety of shapes. Earth bags, you have to have curved walls. I don't think you've ever seen a building that didn't have curved walls. With tires, you can have some straight walls. And I don't know how their attachments work. Usually the earth bags just go right on up and make the cone, make the whole roof. So I don't know that much about them, but I've seen them in a lot of instances. They're cool, but not as cool as tires. All right. Thanks a lot.